Welcome back to Satellite Remote Sensing Day. By now, you should understand the basic concepts of remote sensing, including different types of resolutions, as well as electromagnetic spectrum. In the second module, you will be introduced the concept of satellite climate data records, and what are the major collections of remote sensing data for climate applications. Climate data records, or CDR for short, is defined as a time series of measurements of sufficient length, consistency, and continuity to determine climate variability and change. Satellite data can be used to produce satellite CDRs to study the change of different essential climate variables as defined by the Global Climate Observance System. The essential climate variable, or ECV for short, is a physical, chemical, or biological variable or a group of linked variables that critically contributes to the characterization of Earth's climate. Temperature and rainfall are an example of ECVs that we can observe and monitor using satellite data. To develop satellite CDRs, it is often necessary to use data from multiple satellites. Typically, satellite applications require data with a length longer than 30 years to capture robust signals of climate change. On the other hand, a single satellite platform typically operates for 5 to 10 years before being decommissioned or replaced by other satellites. The satellite sensors will also deteriorate as time goes by. Therefore, we often need to use and combine different remote sensing data from different satellite platforms or sensors for climate applications. Let's use the polar orbiting satellites as an example. The table shows the timeline of the major polar orbiting satellites operated by NOAA and the European Meteorological Space Satellite Agency. You can see a wide range of satellite lifetimes ranging from 3 years to more than 15 years. Also, some sensors on board the satellite may degrade and produce low-quality data at the end of their lifetime. Therefore, it's really critical for us to combine different satellite data to reach a critical length of more than 30 years for climate studies. When we try to process data from multiple satellites to generate satellite CDRs, the process is often called InterSatellite Calibration, which aims to align data from different satellites to produce a consistent time series. In this image, you can see the examples of 3 satellite data of time series across time. You notice the difference between those 3 satellites, and we often need to adjust those data from different satellites to the same reference, or we call it InterSatellite Calibration. The reference data can be data from one satellite or data from other sources. After the adjustment, the data from multiple satellites should be consistent for climate applications, such as identifying the climate trends, as shown in this image. There are different collections of satellite CDRs that are produced by different agencies. NOAA has a collection of 40 satellite CDRs that are routinely updated for different aspects of land, ocean, and atmosphere. All NOAA CDRs are freely accessed via NOAA National Centers for Environmental Information, or 3 major cloud service providers, including Amazon Web Service, Google Cloud, and Microsoft Azure. NASA has a collection of Earth system data records that are available via NASA Earth Data. These datasets can also be used for various climate applications. European Space Agency, ESA, has 26 satellite-based ECVs under its climate change initiative. All 26 CCI data are available via ESA's CCI Open Data Portal. ESA also provides a toolbox to help users use its CCI datasets. In this tutorial today, you will learn more about different satellite CDR datasets available through 3 different agencies. You can explore different type datasets and think about how it can be used in your project.